Good day to you wherever you may be listening from. My name is Mr. Samuel. Um, Today we will be looking into refraction of light. As you've been given the note on refraction of light. So today I will just be giving you a few explanations on the refraction of light. Okay, when we talk about refraction of light, what do we mean? Okay, according to the note given to you, which I would like you to turn to right now, it was given to you in there that refraction hold on, is the bending of light ray as it crosses the boundary between two media of different densities, thus causing change in its direction. Now, when we talk about refraction, let me give you the explanation. We have two different media. Okay, let's say probably let's say two different media, maybe air and glass, or let me just say medium 1 and medium 2. So let's say this is our medium 1. Medium 1 is M1, okay, and medium 2, let's divide it. And medium 2 is what? Is M2. Medium 1, medium 2. Okay, now let's say this is our light ray coming in from medium 1, trying to enter into medium 2. Now, this light ray, we call it the what? The incident ray. The incident ray. Now, also, there's something we always call a normal when we're talking about light ray. A normal, let me give it a diagram like this. I hope it passes through the middle. If not, I will adjust it anyway. Okay. This normal must pass through the middle. Okay. Okay, let me adjust it. Good. Now this is your normal. This is your normal, or let's say that's our normal, and that's the light incident ray. The angle here, which is the angle between the incident and the normal, is called the angle of incidence. High angle of incidence, or you can put the degree angle of incidence. Okay, that's the angle of incidence. And also, remember we said that when the light ray is entering into the second medium, what happens is that it bends away. Okay, it changes direction. Now, as it bends, it will be bending towards the normal in the second medium. Remember that this M1 is the first medium, this is the second medium. Now, in this second medium, your light ray will be bending towards your normal. So let's say we have something of this. Don't worry, I will adjust that. Because this is how it should be. Okay, good. Now it bends away from your word. It bends towards the word, towards the normal, and this will be your refracted ray. This ray is the refracted ray bending towards the word, towards the normal. And this angle here, which is the angle between your incident, between your normal and your refraction, is the what? Is the refraction angle. The refraction angle. Sorry, I'm having an issue with my pen. Is the refraction angle in degree anyway. The refraction angle. Now, this phenomenon of light ray bending from medium 1 when entering medium 2 is being referred to as refraction, and there is a sort of explanation for this, which is called the refractive index. That is the measurement at which an incident ray will be bent when entering a second medium, when entering your medium 2 from medium 1. So this degree of change of bend in direction, or change in direction, or whatever you want to call it, is what we refer to as what? As refractive index. We call it refractive index. Let me have a dotted line to, okay, good. Now we call it refractive index. Our refractive index is always being said to be refractive index of medium 2 with respect to medium 1, and this is how we represent our refractive index of medium 2 with respect to medium 1. Now, this our refractive index can be said to be the speed of ray in medium 1 to the speed of ray in medium 2. That is speed in M1 all over speed in M2. The speed at which your light ray is entering from medium 1 into medium 2. Okay. Now recall that your speed, okay, when you talk about, when we discussed about, we did something about wave speed, and we said that wave speed equals to frequency times wavelength. Also, you see there is a lot of relationship between your light ray and your wave. In fact, there's something we call the light ray particle duality. That is, there are some characteristics that we have in light ray that we also possess that we also have in what? In wave. So when we say speed, okay, the speed of your light ray is what? Frequency times wavelength, which can be said to be F lambda. Which means for this M1, M2 will be equal to what? F lambda 1, F lambda 2. Now, if you look at what I've written here, I have frequency, lambda 1, lambda 2. Why not frequency 1 and frequency 2? The reason is because your frequency always remain the same. Okay, when you are having your light ray moving from one medium into another, the frequency remains the same while the wavelength changes. Okay, so what I'm saying is that our F1 will be equal to F2, then will be equal to F. So there's no need writing maybe F1 or F2. So that's why we have it there like that. Okay, let's move forward a bit. Okay, now let me continue. Let's go to a new page. Remember, we said that our, let's divide it into 2. Yeah. Good. Remember, we said that our refractive index of medium 2 with respect to medium 1 will be equal to speed in medium 1 over speed in medium 2, and we said it will be F lambda 1 over F lambda 2, which means our frequency will cancel frequency since it's the same. Then we are going to have lambda 1 over lambda 2, that is wavelength in medium 1 over wavelength in medium 2. Also, we can also have our refractive index to be, let's say, refractive index of medium 2 with respect to medium 1 can also be written as the sine of the angle of incidence in M1 over sine of angle of refraction in M2. Sine of angle of incidence in M1 over sine of angle of refraction in M2, which leaves us with, let's say, M1, M2 equals to what? Sine high over sine high. Okay, sorry for that glitch. Sine high over what? Over sine high. Now, if M1 equals to A and M2 equals to glass, okay, that means we are going to be having our refractive index to be equals to wavelength of air over wavelength of glass. Then it can also be or sine high over sine, sorry for that glitch again, over sine what's going on? Sine high over sine high. Okay, also, we said the light is moving from medium 1 into medium 2, or we can say from hair to glass, since our medium 1 is air and our medium 2 is glass. Also, the hair can be, or the ray can be also be moving from glass back into hair. Now, if it's moving from glass back into hair, which means it will be, let's say it's now moving from glass back into hair. Refractive index for glass back into hair will now be equal to, let's deal with this first, wavelength of glass, wavelength of ray in glass over wavelength of the ray in hair. Now, looking at this and this, the refractive index of hair to glass and the refractive index of glass to hair, you can see that there is a sort of I can call it relationship between them. Yes. And what is that? If you look at this, looking at this, it is the inverse of the first one. Okay, I can say A will be equal to, let's say, 1 over glass A. And with our mathematical knowledge, okay, going with our mathematical knowledge, let me expand this a bit. We can now say that this, everything here can be written as G equals to what? This is 1 over 1 times refractive index of air, wavelength of air over wavelength of glass. Now everything we have here, let's call this 3. Let's call this equation 3. Okay. Let me pick a color. Let's call this 3. Let's call this 3, and let's come over here and call this 2. Let's call this 2. Then okay. Now looking at this our 3 and 2, you will agree with me that this that we have here is the same thing as saying what? As looking at our 2. What we have here is the same thing as what we have in 2. Okay, which means this is equally saying that we can now say that you can see that it is what? Glass to hair. Glass to hair. Okay, the wavelength of glass over wavelength of air, which is equal to what? Which is equal to this over A. I mean, refractive index of glass to hair, which means we can now go back and say our. Okay, let's go to a new page. Let me give us a new page. Okay, then we can now say that our refractive index, let's divide it again as usual. Sorry. Then we can now say that our refractive index of air to glass is equal to 1 over what? 1 over glass to hair. 1 over glass to hair. Considering what we remember we wrote something in the previous page where we said our A particularly this glass equals to 1 over wavelength of glass over wavelength of air. I think you can recall this, and we know that everything that we have here is what? Is this? Is saying glass to hair equals to what? Equals to okay, so this is the relationship. This let me show you one. So this is the relationship between what? Between refractive index of air to glass and refractive index of glass to hair. Refractive index of air to glass and refractive index of air to glass. Also, remember we said earlier that A refractive index to glass equals to sine high over sine hard. Okay, so now when you want to do that of glass to hair, because it's like you are just doing it in a reverse process, just like we have in the case of our wavelength of glass to hair and wavelength of hair to glass. Now for your glass to hair, it will now become glass to hair. It will now become sine hard over sine high. I believe you will agree with me that this is the inverse of what? Of of this is inverse of 1 over, it's also equal to 1 over sine high over sine high. And remember that everything that we have here is equal to your what? Is equal to AN over G. Sorry. Refracting index of air to glass. So that's just the relationship between our refracting index of air to glass and glass to air. That is the proving of that. Now remember, let me just bring back our memory. Remember, I've given you let's say 3 different formulas. Anyway, the first one is that I said when you're talking about air to glass, okay, it can be sine high over sine high, or it can be what? It can be wavelength in air over wavelength in glass. And these are the 2 major formula. And I also said that you can have your glass to air to be equal to what? 1 over air to glass. 1 over air to glass. Now let me give you a few calculation on this. Okay, or let me take us back a bit so that you can just refresh your memory. Can we do this? Okay. 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 So okay, we said this the other time, and we also have this. Okay, going back a bit. Okay. Let's solve a question. Let's solve a what? A question. And to solve that question, I would like us to go a bit into reality. Okay, let's look at question number 1. Question number 1 says that a beam of light incident from air to water. A beam of light incident from air to water at an angle of 30 degrees. Find the angle of refraction if the refractive index of water is 4 over 3. Find the what? Find the angle of refraction if the refractive index of water is 4 over 3. Now, I have told us earlier, that, let me draw. Okay. I told us earlier that when we talk about refraction, refractive index rather, we say from medium 2 with respect to medium 1. Refractive index of medium 2 to respect to medium 1. The question is that what? We have ray of light, okay, that has an angle of incidence of 30 degrees. An angle of incidence of what? Of 30 degrees. Angle of incidence of 30 degrees. And mind you, we have been told that the beam of light is incident from air to water. From air to water. That means we are dealing with something of this nature. Air to water. Okay. And we are now being told that we should find the angle of refraction. Refraction is unknown. Find the angle of refraction if your refracting index of water. Sorry, I made a mistake there. I wrote glass again. it should be water. If the refractive index of water with respect to glass, or to air rather, of water with respect to air is what? 4/3. Now remember, we have our first formula, second formula, and we have our third formula. Anyway, from all these three formulas, which one best fit for the question at hand? First of all, let us look at what we have. Over here we have refractive index. Do we have refractive index? Yes, we have refractive index. Okay, then we have our what? Sin high. Do we have angle high? Yes, we have angle high, our angle of incidence. Then we are left with what? Our angle of refraction, and that is exactly what we have to calculate. Okay, now when you are dealing with any formula that you want to use, remember one thing: you must have only one unknown. You must have only one unknown. If you look at this second formula, although we have this, okay, but we don't know our wavelength in air, and neither do we know our wavelength in glass, so we cannot use this formula. We cannot use the second formula, but the first formula is very okay. So now, using equals to sin I over sin R, it will be what? 4/3 to be equal to what? What is sin I? Sin 30 all over sin R. Sin 30 all over sin R. Without much ado, let's continue. The next thing to do is to what? Okay, is to make our sin R subject of the formula. Okay, let me take you back a bit to your junior class days. What do? You cross, multiply, and what do we have here? To be 4 sin R to be equals to 3 sin 30. 4 sin R equals to 3 sin 30. What do we have? Remember that our sin 30 is what? 0.5. That is 3 multiplied by 0.5. Then our sin R will be equals to 3 times 0.5 all over 4. Now, our sin R equals to 1.5. Sorry, let me write that again. 1.5 all over 4. And when you do that, you are going to have 0.375. This is my 5. Sorry. Okay, I don't want us to move to the next page yet because of the calculation, so I'm going to scroll up a bit. I'm going to extend. Okay, then what we're actually looking for is our what? Is our R, not sin R. Okay, is the main angle we are looking for. So our R will be equals to sine inverse of 0.375. Sine inverse of 0.375. Can you point out the calculator and tell me what you have? Then the answer is what? 22.02. Let's leave it in 3 decimal places. 024 degrees, and that's the angle of what? Angle of refraction. Okay, and you can, if you like, you can now approximate it to the what? 22 degrees. Remember, we were given our sine high as what? As 30 degrees. Now we are getting our we are given our angle of incidence as 30 degrees. Now we are getting our angle of refraction to be what? To be 22 degrees. That shows that there is a reduction in the angle. Okay, the angle of incidence is bigger than the angle of refraction. There's a reduction in that. So that's that about that. Okay, everybody, let's go for our second example. I've drawn that already, just not to waste our time. Now, the question says that in the figure to your left shows the path of light passing through a glass block. Calculate the refractive index of the glass. Calculate the refractive index of the glass. The refractive index of the glass. That is what we are meant to calculate. Let me just adjust this a bit. Okay. Now, looking at this, anyway, if you look at this, let's start solving this question one after the other. Remember, when we want to solve questions, the first thing we do is to do what we itemize the parameters. First, this will be our incidence ray. This is the refracted ray. We call this the emergence ray. Let this be like that. Now this is our angle of incidence, high, and this is our angle of refraction, high. Okay, so from this, our angle of incidence, remember that everything here, let me use my colored pen to show that everything here is 90, as everything here will also be 90. Okay, which means for us to find our angle of incidence, our angle of incidence will now be what? Let me use red for this. Our high will be equal to, if everything here is 90, then I will be equal to 90 minus 30, which is equal to 60 degrees. I believe we are not supposed to be having a problem with that. And also for our refraction, angle of refraction, everything over here is 90, right? Which means our R will be equal to 90 minus 60, which is equals to, sorry, technical glitch, which is equals to what? Let me go back a bit, which is equals to 30 degrees. Okay, so we have our angle of incidence, we have our angle of refraction. Now let's go back to our formulas. Let's recall our formulas. We are looking for, we are not even, were we told the medium they are from? Okay, we are not even told about, in fact we don't even know the medium. We don't know, maybe it is air or water, but although from this is definitely from air to glass anyway, because the air is entering into the glass. This is our rectangular block, and the light is entering from the air into the glass. So now let's go into this. Our refractive index from air to glass. What's the first formula? Formula, we say wavelength of air over wavelength in glass. We don't know this. The second one is what? We said sine high over sine r. Sine r over sine r. Then you can see that we know our height to be 60 degrees, and we know our r to be what? To be 30 degrees. So this formula is a go. You can use this formula. You can use this formula. Okay. Let's move on. Okay, let's scroll up a bit. So, since we have this formula, I can come down and say, let's solve. Let's say that our equals to what? Sine 60 over sine 30, which will be equal to what? What's our sine 60? Our sine 60 will be what? 0.8660 all over what? 0.5. So when you do this, what are you going to get as your answer? Our answer is what? Our effective index of air to glass now will definitely be what? 1.73. And that's the answer. There are so many questions to solve on this, but I'm just going to stop here. Okay, I'm just going to stop here, and let's hope that you will solve more in your assignments, and I want to believe that you also work on some. I've told you, if you don't have this textbook or all inclusive calculations in physics, please try and get it. It's very good. Okay, it's very good. And so I will give you your assignment on your Google Classroom. I will send the assignment there for the calculation aspect, and you will submit as I told you. Thank you very much. Have a nice day.